Professor Bialis here. In this video we are going to be covering section 2.4, which is an introduction to problem solving, aka introduction to word problems. I know that a lot of people do not like word problems and they are something that brings a lot of anxiety and stress, but they are important. They are necessary. Without word problems and applications, all that mathematical algebraic stuff we do is honestly completely useless. We have to use it for something. Okay, so what we're going to do in this section is just talk about some very basic scenarios and see how we can organize the data. Okay, the scenarios we're going to be doing are not going to be necessarily something you're going to do on a day-to-day basis in your job. But the purpose of this is just to give you a general, simple scenario to show you how we can organize our thoughts, how we can pull situations together into equations, how we can solve it. That's all. Okay? There will be even some times where you look at a problem and you can just kind of jumble the numbers in your head and you get the answer. And if you can do that, fine. I suggest, though, try to do the algebraic aspect of it, because if the numbers aren't so nice and clean, you won't be able to just think about them. You can think about a 3, a 6, and a 12, okay? But you may not be able to think of a 4.72, a square root of 3, and 11.89. Okay, so the algebraic methods we have help us organize without having to rush through and calculate everything in our head or jotting things down on a piece of paper. Okay. Now, before we get into some examples, I want to be very clear on the process of how we can break down these problems. The book introduces a 4-step procedure, okay? And those 4 steps are understand, translate, solve, and interpret. That's what we have to be doing in these word problems. No matter what application it is, these are the 4 phases of these problems. Now, a lot of people, they worry about this solve and translate part. Translate means write an equation. Solve the equation. And then interpret means make sure you answer the question that they're really asking. This understand is where most people kind of gloss over it. Okay? Understanding the problem is of the utmost importance. You need to know what the heck they're talking about before you can even think about translating. I've seen a lot of people over the years that I've been teaching, and they look at a problem, they read it, and they say, I have no idea what they're talking about. Because you read through it once. You need to read through these problems 5, 6 times before you can hope to get to that equation. Okay? And I'm going to show you that process as we're going through the examples today. But don't be afraid to read through this problem 2 or 3 times before you write anything down. That's part of the process. That's normal. That's what we should all be doing. It's not read it once and boom, here's your equation. So be patient and understand what they're talking about. Carefully write down the equation. Once you have that, then you're home free. It's not a word problem anymore. You solve the equation and boom, you got your answer. Okay, so take your time at the beginning. And if you're a slow reader, don't worry about it. I'm a slow reader as well, and I can get through these questions very quickly because they're short. They're not a page long that you have to read through. There's 2, maybe 3 sentences. That's it. Okay, so take your time, read through it, and you'll be fine. The examples I'm going to go through are found in the textbook. Every section in the textbook has an example problem fully worked out, and then right after it they have a practice problem that's just like the example that's not worked out. I'm going to go through those practice problems with you in this video. And any video that we do with word problems in the future, that's where I'm going to be getting my examples. So this first problem that we're going to do again, this is section 2.4. I'm going to do practice 1. Practice 1 is found on page 107. Okay, and again, it will have a practice 1 like a little green box next to it. Practice 1 says, 3 times a number minus 6 is the same as 2 times a number plus 3. Find the number. Got it? I'm just kidding. I don't want you to get it after that quick read through. I did that on purpose because I don't want to be thinking about all the different details that I'm reading. I just want to know what we're talking about. Again, it says 3 times a number minus 6 is the same as 2 times a number plus 3. Find the number. Okay, what are we talking about? Are we talking about, cars? Are we talking about, cups of sugar? We're talking about numbers. That's all I want you to get out of the first one or maybe 2 read-throughs. We're talking about numbers. We have a number problem. When we have a number problem, it basically comes down to translate it into an algebraic equation and solve. So we just have to translate. Okay? So one more time. 3 times a number minus 6 is the same as 2 times a number plus 3. Find the number. Now, whenever I translate an equation, there's going to be one side of it and then another side of it. Translate up to the equal sign first. In this problem, it specifically says, is the same as. That phrase means equals. So I'm not going to read past that. I'm just going to go back to 3 times a number minus 6 is the same as. 3 times a number, and then there's a comma. Minus 6 is the same as. 3 times a number minus 6 is the same as. 3 times a number minus 6 is the same as. I didn't read that once and throw it on the board. I had to read it multiple times and repeat it and picture it and then write it down. Okay, now I can move on. Is the same as 2 times a number plus 3. 2 times a number plus 3. 2 times a number plus 3. That's it. Okay? 3 times a number minus 6 is the same as 2 times a number plus 3. That's what it takes. And as you do more and more of these, as you get more comfortable, that time will start to shorten and you'll be able to speed up a little bit. But right now, especially if you've been struggling with this your whole life, forget that. This is your fresh start, but be smart about it. Don't look at it and say, I don't know what it means. Okay? Read it again and try to understand what it means. So I understood it, I translated it, now I have to solve. So I go through the 6 steps of solving. First thing I do, bring that 2x over to get the variable on one side. I got x minus 6 equals 3. And then I undo that minus 6 by adding it. And x equals 9. And there's my answer. Now, when we get to the end of this, don't just circle this and that's it. Sometimes that is your answer, but make sure that that's what we're looking for. It says find the number. X was your number, we're good to go. Okay? But when they have interpret at the end, that means make sure that this is actually what you were looking for. Because sometimes we have to do a little bit more with that value. Let's go on to practice 2. Practice 2 can be found also on page 107 on the bottom. And it reads, 3 times a number decreased by 4 is the same as double the difference of the number and 1. 3 times a number decreased by 4 is the same as double the difference of a number and 1. Again, I just want to know what we're talking about. We're talking about numbers. Therefore, we're simply translating. That's all. I translate up to the equal sign first. 3 times a number decreased by 4 is the same as. Stop. Do that first. 3 times a number, and as you're looking at the problem, it has a comma. Decreased by 4. 3 times a number decreased by 4. 3 times a number, then I decrease that by 4. Okay, that comma tells you to multiply first, then decrease it by 4. We're not going to go, decrease it by 4, then multiply by 3. So that comma is very important. Is the same as. Okay, now pay attention to the wording on the rest of it. Double the difference of the number and 1. Double the difference of the number and 1. Double means I multiply by 2. I'm doubling a difference. That's where those parentheses are going to be coming from, because we want to hold that difference, that subtraction together. The difference of the number and 1. 3 times a number decreased by 4 is the same as doubling a difference of a number and 1. And now I solve. But I make absolutely certain that this is correct before I go ahead and solve, because if you solve something that's wrong, you're just wasting your time. Okay, now I go ahead and solve. I distribute. I get the variable on one side. Don't lose that negative on the 2. I add the 4. And I get x equals 2. And again, they were looking for a number. There's your number. We're good to go. Okay? Those are your number problems. You translate, you move on. Just take your time. Don't rush, and you will be fine. Let's now go into practice 3. Practice theory 3 can be found on page 108. All the way on the bottom, and it reads, a 45-inch board is to be cut into 2 pieces so that the longer piece is 4 times the shorter. Find the length of each piece. Okay? Now this isn't just numbers. Now we're talking about a board being cut into 2 pieces. Okay? If you want to list this or if you want to draw a picture, whatever works for you. Okay? If the picture gets too complicated, I honestly like to go to lists. But in this case, there's a board. That's all it takes. Okay? I have a board that was 45 inches long. So this entire thing is 45 inches long. Okay? Then it says that it was cut into 2 pieces. Now notice they didn't say cut in half. So I don't want to cut that in half because then my brain's going to say, wait a minute, just divide by 2. Okay? They were cut so that there's a shorter piece and a longer piece. Okay? Now it says that the longer piece is 4 times the shorter. Notice they mentioned both a longer and a shorter piece, but they said nothing about the shorter. The longer piece is blah, blah, blah. But the shorter piece was just named. That's it. Whatever they say nothing about, that's your variable, because it's just a blank spot. But then you go on and it says that the longer one was 4 times the shorter. 4 times that shorter piece, 4x. Those are your pieces of the puzzle. Now it's up to us to pull that together. Okay? So again, yes, we're cutting a board here, but any problem where they give you a bunch of description, now how can we pull that together? We can pull this together by saying those 2 pieces should combine back to that original 45 inches that we started with. And now we can solve. So I'm going to combine like terms, and then I'm going to divide by 5. And x equals 9. Now, make sure you interpret, okay? They asked for what is the length of each piece. Don't just circle 9 and that's it. 9 was your shorter piece, correct? So your shorter piece is 9 inches, but then your longer piece has to be 4 times that. 4 times 9 is 36 inches. That's the interpretation piece at the end that we got to be careful with. Make sure you actually answer the question. Okay? Let's go on to practice 4. Practice 4 can be found on page 109. Toward the bottom. Practice 4 reads, in 2015, there were 7 fewer Democratic state governors than Republican state governors. Find the number of state governors from each party. Alaska had an independent governor, so use a total of 49, representing the other 49 states. Okay? Now, again, what are we talking about? We're talking about state governors, and we're talking about them specifically as Democrats and Republicans. Okay? I'm not going to be drawing anything with this. Here I'm definitely going to be listing what I have. Again, they talk about Democrats, they talk about Republicans. You don't have to have some long drawn out list here. I've got Democrats, I've got Republicans. Okay? Now, what about the Democrats and Republicans? We're talking about the number of Democrats, number of Republicans. Okay? Now, let's see if we can describe those. Again, it says in 2015 there were 7 fewer Democratic state governors than Republican state governors. 7 fewer Democrats than Republicans. Which one did they say nothing about? Notice the recurring theme here. They said nothing about Republicans. So I'm going to make that my variable. Now I'm going to use R as my variable, so when I find R, I know what I have. So the Democrats were 7 fewer. So whatever the Republicans had, I have to lessen it by 7. And those are algebraic representations of the number of Democrats, number of Republicans. Okay? Now, it then goes on to say that find the number of state governors for each party. Alaska has an independent. Now, normally there's 50 states, so there's 50 governors altogether. But since Alaska had an independent, we're just going to look for a total of 49. Okay? So, total means the number of Democrats plus the number of Republicans should total 49. And now this is something I can solve. So again, what did I do? I listed the pieces of the puzzle, and then I find a way to pull them together. Same way I did here. I listed the pieces of the puzzle, I find a way to pull them together. Okay? Combine like terms. I add a 7. And I get 56. Divide by 2. And R equals 28. Now, again, I used R for a reason. That tells me that there were 28 Republican state governors, and they wanted to know how many Democrats there were as well. Democrats, R minus 7. 28 minus 7 is 21. So Republicans had 28 governors, and then Democrats, 21 governors. And that's it. Okay? I've had students over the years say, it's so easy when you talk about it, but when I go and do it myself, I can't do it. Again, most of the time, it's because those students go home and they read a problem and say, I read it once, I don't know what to do. Read it again, read it again, read it again. Start writing things down. Maybe you'll write something down that's incorrect. That's okay. Because sometimes you need to see the wrong answer to know what the right answer should be. So start the process. Don't just sit there and stare at it and don't write anything down. Try something out. Because sometimes doing the wrong thing will take you down the right path eventually. Okay? Let's move on. That was practice 4. Practice 5 is on page 110. Erase the board a little bit. Practice 5 says, the second angle of a triangle measures 3 times as large as the first. If the third angle measures 55 degrees more than the first, find the measures of all 3 angles. Okay? So, again, what we're talking about here is a triangle and the 3 angles within that triangle. If you want to, you can draw the triangle. You can list first, second, third, because they do mention first angle, second angle, and third angle. Whatever you prefer, okay? You can do both if you want to. Here's a triangle. You've got a first angle, a second angle, and a third angle. Again, if I had to choose one, I personally like using a list. But if you're more of a visual drawing person, go for it. Whatever works for you. Okay, now let's go back and get some more information out of it. It says, the second angle of a triangle measures 3 times as large as the first. Again, they mention the second and the first, but they say nothing about the first. So I'm going to make this x. The second angle was 3 times that first angle. So here I can make this x and this 3x. Okay, then I move on. It says the third angle measures 55 more than the first. The third is the first angle, but then 55 more than that. and there are 3 angles. After that, all it says is find the measures of all 3 angles. That's it. Now, remember, in the last 2 problems, they gave you a total length for a board. They gave you the total number of governors. Here, they don't really say anything. This is some information we need to come to the table with already. Remember, all 3 angles of a triangle should always add up to 180 degrees. So we need to come to the table knowing that. We should know that if I take those angles, add them up, I should get 180. And there's my equation. I understood the problem, I translated it. Now I need to solve the equation. So 3 plus 1 plus 1 is 5x. I'm going to subtract 55. Now be careful. 180 minus 50 is 130. Minus that extra 5 is 125. I then divide by 5. Okay? Now, if you need, again, don't jump to a calculator with that. If you have to, don't be afraid to go off to the side here. Okay? If you can do it in your head, great. If you can say, hey, it's 25, great. But if you need to, go here. 5 goes into 12 twice to get a 10. 12 minus 10 is 2. Bring down that. 5 goes into 25 5 times. And then you've got 25. It doesn't take very long. So you've got x is 25. Are we done? No. That was the solving, but now we need to interpret that solution. If this is 25, that means my first angle was 25 degrees. My second one is 3 times that, so 75 degrees. And then the third one is 55 more than this. So that is 80 degrees. And there we go. Okay, so sometimes there are going to be some pieces of information that we need to remember from the past. Now that's why it's important you go through these problems in your assignments so that you'll see what type of information you're going to be asked about. Okay, on the exams there's not going to be any kind of surprise. Like, hey, remember that thing from 3 years ago we didn't talk about at all in this? It's all going to be stuff that you have encountered on the previous assignments. Okay, so let's do one more. Practice 6, found on page 111. And practice 6 reads, the sum of 3 consecutive even integers is 144. Find the integers. Now, in the previous section, we talked about this idea of consecutive integers. First thing that you should be thinking about is how many. They say that there are 3 consecutive even integers. So if there's 3, I have a first, I have a second, I have a third. And no matter what, my first is always x. It's always going to be the case. Okay? Next, it says they were consecutive even integers. Remember, when they're even integers, what are we adding? We're adding 2 and then another 2 to make a 4. Those are your pieces to the puzzle. Okay? Now, what we didn't have in the previous section is this next part. It says their sum is 144. Okay? Now they're actually telling us if I add these up, if I take those and add them, I should get 144. Now I have a complete thought that I can solve. Okay, so I've got 3x plus 6. All I did there was combine those like terms on the left. I then subtract a 6. I've got 3x equals 138. And then I divide by 3. And what I get is 46. Now again, interpret. They wanted the integers. X is my first, 46. Then I add 2 to get 48. Now be careful. What I see some people do is they say 52. Because they say 48 plus 4 is 52. But that 4 was added to X. X plus 4. 46 plus 4 is a 50. And that's where the consecutive list of numbers comes from. So just be careful on that last one, because that's a very common mistake people make. Okay, that's pretty much it. Okay, so these are very basic scenarios for you to get kind of your feet wet in this process and to just practice some general organization of these ideas. We are going to grow from here, but these same basic concepts are going to be involved all the way through. Okay, so as always, work hard. Let me know if you have any questions, and I'll see you next time.